Let's implement a function to remove the data from the list. Function name remove, and then we provide a position of the data to be removed. So implementation as list class name remove int position is provided. So let's validate the position value. It should be 0 or positive, and then the maximum position is a count minus 1 as if it's an array. And then let's consider how many cases we need to process. So let's draw a picture. We have a list object, pointers, and then counter. So we have a node linked together, very last one, next one, next one, next one, and the like. So this is a head pointer, and this is a tail pointer. So the number of cases we need to consider in removing a node is that left hand side and right hand side. If we have only one node, count is one single node only, left hand side is list, right hand side is nothing, one single node. And then if we have more than one node, if we remove the very last one, then left hand side is node, right hand side is null. This is the tail node to remove. Is there. Then even if we have more than one node, but if we remove the very first one, then left hand side is list, right hand side is node. That's a position is 1. Position is 0, the very first node. Otherwise, node and the node. The rest is between two nodes. That's the case. So let's implement one by one. So when count is 1, if count is 1, the only node, the first case, we are considering that, we need to free the memory. So this is the only one. To free the memory, delete, and then address. Address is at head or tail. Either one you can use. But after removing the node, head and the tail becomes a null pointer. And then second case, let's consider the third case when position is 0. Else if position is 0, the very first node that we are going to remove, which is actually top of stack. Same operation. We just give a bypass link. Consider this is top of the stack pointer, then we give a bypass link. So remember that we need to save address. Currently, the very first node is pointed by head, so that we can free the memory once we complete all operations. We need to free the memory. That's what we need to do. And then we just set up bypass link. Head moves to the next link, the bypass link. Then we remove the very first node. And then the one between the two and last, the problem is we don't have a direct in all the information directly, so we need to move through the link and then delete it. So let's do that in the next video for the rest of the cases. But here let's test the one. So what you can test is the only node or at position 0. So here at position 0, from mm, here is the current one, we can remove from position 0. So mm, remove, position 0, then 15 is removed. The leftover is 99, 77, 10, 20 is the one. So we can assert that. Let me copy those 4 cases. Then 99 is a position 0, position 1, 2, 3. That's the one. And size will be 4. That's what we expect. Compile and run. and size is not, so size is not reduced because I forgot to decrease the count after removing successfully. So compile and run. Okay, so let's remove more. Remove a 0 is implemented. Then remove 0 again, so 99, 77, let's one more, and 10 is removed. So now only 20 is left over. So the position 0, the value is 20, and now size is 1. And then if I remove one more time, all gone, then size should be 0. That's what we expect. Compile and run. So we have tested so first two cases of removing.